Good day everyone, welcome back to our discussion on the topic indices. Today we will be discussing indices that either lead to simultaneous equation or quadratic equation. Now our very first question we'll be attempting is from November 2000. It states that solve for s and y in the equation 2 raised to the power of s plus 3 raised to the power of y equals to 9 and 2 raised to the power of s plus 2 minus 3 raised to the power of y plus 1 equals to 8. We have to leave our answer to 3 decimal places. Now the first thing we are going to do, we are going to present the indices properly to reflect 2 raised to the power of s and 3 raised to the power of y. Now our equations becomes 2 raised to the power of s plus 3 raised to the power of y equals to 9 and 4 in brackets 2 raised to the power of s minus 3 in bracket 3 raised to the power of y equals to 8. The next thing we are going to do, we are going to represent 2 raised to the power of s with p and 3 raised to the power of y with q. This makes our equation become p plus q equals to 9 and 4p minus 3q equals to 8. Obviously, we are now left with a simultaneous equation with two unknown, p and q. Now to solve our simultaneous equation, we are going to multiply equation 1 by 3 and add both equations together. So doing so, 3p plus 4p will be equals to 7p. Our q is going to cancel out because plus 3q minus 3q will be equals to 0. And 27 plus 8 will be equals to 35. Now this breaks down to p equals to 35 over 7, which is 5. Now substituting p equals to 5 into equation 1, equation 1 becomes 5 plus q equals to 9 and q will be equals to 9 minus 5, which makes q to be equal to 4. Now remember, both p and q is 2 raised to the power of s and 3 raised to the power of y. So changing back to 2 raised to the power of s and 3 raised to the power of y, 2 raised to the power of s will be equals to p and 3 raised to the power of y will be equals to q. Therefore 2 to the power of s will be equals to 5 and 3 raised to the power of y will be equals to 4. Now to be able to get s and y, we have to change from indices to logarithm. S becomes log base 2 5 and y become log base 3 4. Next, to be able to get s and y, we have to change the bases. So our equation becomes s will now be equals to log 2 5, which is also equals to log 10 5 divided by log 10 2, and the same thing for y. Y becomes log 10 4 and log 10 3. So therefore s will be equals to log base 10 5 is 0.6990 and log 10 2 is equals to 0.3010. And for y, log 10 4 is equal to 0.6021 and log 10 3 is equal to 0.4771. Now when we divide this, our s will be equals to 2.322 and y will be equals to 1.262 to 3 decimal places. Now for questions that are quadratic in nature, we have this example from NECO. It says solve the equation 4 raised to the power of 2s minus 3 minus 3 in bracket 4 raised to the power of s minus 2 minus 1 equals to 0. First, we need to clear the minus power as follows: 4 raised to the power of 2s divided by 4 raised to the power of 3 minus 3 in bracket 4 raised to the power of s divided by 4 raised to the power of 2 minus 1 equals to 0. To clear out the fraction, we multiply by the highest power of the denominator, which is 4 raised to the power of 3. And after doing so, we are left with 4 raised to the power of 2s minus 3 times 4 raised to the power of 1 in bracket 4 raised to the power of s minus 4 raised to the power of 3 equals to 0. Now we rearrange our equation to become 4s to the power of 2 minus 12 in bracket 4 raised to the power of s minus 64 equals to 0. At this point, we'll say let p be equals to 4 raised to the power of s. Now substituting p for 4 raised to the power of s in the equation, our equation becomes p squared minus 12p minus 64 equals to 0. Factorizing, it becomes p squared minus 16p plus 4p minus 54 equals to 0. And while we factorize both sides, it becomes p in bracket p minus 16 plus 4 in bracket p minus 16, which breaks down to p minus 16 in bracket p plus 4 in bracket equals to 0. Now p minus 16 will be equals to 0, or p plus 4 will be equals to 0, and p will be equals to 16 or minus 4. Now substituting the value for p, we know that p equals to 4 raised to the power of s. This becomes 16 equals to 4 raised to the power of s. Now changing to the same base, it becomes 4 squared equals to 4 raised to the power of s. And since its bases are the same, we equate powers. Thus 2 will be equals to s and s equals to 2. Now our next question is also from NECO. It states that solve for s if 8 e raised to the power of s plus 15 e raised to the power of minus s is equal to 26. Now for our solution, we cannot work with the negative power of e raised to the power of s, so we are going to simplify the left hand side. Our equation becomes 8 e raised to the power of s plus 15 divided by e raised to the power of s will be equal to 26. Simplifying the fraction, the left hand side becomes 8 e raised to the power of 2s plus 15 divided by e raised to the power of s, which is equal to 26. Now we cross multiply to clear the fraction, and our equation becomes 8 e raised to the power of 2s plus 15 will be equals to 26e raised to the power of s. Rearranging, our equation becomes 8 e raised to the power of s in bracket raised to the power of 2 minus 26 e raised to the power of s plus 15 equal to 0. Now let p be equals to e raised to the power of s. Our equation becomes 8p squared minus 26p plus 15 equals to 0. Now factorizing our equation, it becomes 8p squared minus 20p minus 6p plus 15 equals to 0, which breaks down to 4p in bracket 2p minus 5 close bracket minus 3 in bracket 2p minus 5 equals to 0, which further simplifies to 2p minus 5 in bracket 4p minus 3 in bracket equals to 0. So at this point, 2p minus 5 will be equals to 0, or 4p minus 3 will be equals to 0. So 2p will be equals to 5, or 4p will be equals to 3. Therefore, p equals to 5 over 2 or 3 over 4. Thus, e raised to the power of s is either 5 over 2 or 3 over 4, because recall, p is equals to e raised to the power of s. Now changing from indices to logarithm, s will be equals to ln 5 over 2 or ln 3 over 4. Therefore s is equals to ln 5 minus ln 2, which is equals to 0.916, or ln 3 minus ln 4, which is 0.288 minus 0.288. So therefore s is equals to 0.916 or minus 0.288. Our next question says that solve 9e raised to the power of 2s minus 30e raised to the power of s plus 25 equals to 0, and we are given the options. Now for our solution, we are going to show the quadratic equation properly, and our equation becomes 9 in bracket e raised to the power of s square minus 30e raised to the power of s plus 25 equals to 0. Let p be equals to e raised to the power of s. Our equation becomes 9p squared minus 30p plus 25 equals to 0. And factorizing, it becomes 9p squared minus 15p minus 15p plus 25 equals to 0. Factorizing the equation, it becomes 3p in bracket 3p minus 5 in bracket 3p minus 5 equals to 0. This further breaks down to 3p minus 5 in bracket 3p minus 5 in bracket equals to 0. So we have 3p minus 5 equals to 0 twice, and p will be equals to 5 over 3 twice. Now changing back to e raised to the power of s, e raised to the power of s will be equals to 5 over 3. And from indices, s will be equals to ln 5 over 3, which is equals to ln 5 minus ln 3, which is the correct option is D. Here are some exercises for you to try your hands on. The answers to these questions are found in our Indices Further Mathematics textbook. You can easily get our soft copy in the site at the corner of your screen. Thank you.